Alrighty, so identify where a function increasing, decreasing, so determine blah. Alright, so first, since we're talking about concavity, and wait, not concavity yet, concavity's the next one. We're talking about mins and maxes, so now, if I'm talking about increasing, that means that I want my slope to be positive, right? And if it's decreasing, the slope is? Negative. Okay, good. So, where the function increasing, decreasing. So now let's start by taking the derivative. F prime of x is going to be 2/3 x squared minus 1 to the negative 1/3 times 2x. Right? Yes? Hopefully? Okay. Alright, so now given that much information, let's go through and set that equal to 0. So when I set this equal 0, I get, let me see, I'm going to clean up a little. So that's going to make it 4x over 3 quantity x squared minus 1 to the positive 1/3. So this is the only type I really like having fractions for this, because we could actually try to clear out everything to get rid of the fractions. What would I do to get rid of the fractions here? Multiply both sides by the denominator, right? Ooh, anything times 0 is 0, so all that goes away, right? All that goes away, so I should get 0 equals 4x, so x is 0. Okay. So I know because of that I'm going to have one of my critical points there, right? Okay, so now, given this much information right here, so what is my domain of this? What is the domain? Because it's going to be a 2/3, right? This 2/3 fractional exponent, what does that mean? Is there any restrictions on that? What if it was to the 1/2? Can't have negative, right? Can't have negative. If it was to 1/2, I could not have negative, because that would mean that I would have imaginaries there, right?
Yeah.
Like you're zoning out. I get like about ready to fall asleep. Okay. All right. So, but is there any restrictions on this domain here? Having a cube root, right? Is there any restrictions on the cube root? No, there's not. I'm allowed to have negatives in the cube root, so that's important. So looking at critical values, so restrictions, places where I cannot have this, asymptotes, okay, all those things. Okay, so I don't have any of those. Okay, because of that, I'm good. Now, let's take a look. It's going to be equal to 0. All right, so number line wise, 0's right there in the middle. So I know that left hand and right hand of this are going to be different parts. Okay, increasing, decreasing. So now I'm going to plug in numbers on both sides to see what I get. So if I plug in a -1, plug in -1, I would be checking everything from the left hand side of this. So plug in -1 to my derivative. And let's see, so -1, so right here, so -1, that would be, bottom should be 0. Uh-oh. Okay, -1 doesn't work for me, does it? No? Okay, so -1 doesn't work, right? Okay, what about -2? Would -2 work then? Okay, what does that tell me about the derivative at -1? Okay, I have an undefined derivative?
Wait.
That's kind of weird, right?
Very.
Yeah, it is, isn't it? Okay, so we'll address that here in a second. All right, let's try that -2 then. So negative 2 squared is 4. 4 minus 1 is 3, right? Okay. Cube root of 3. Cube root of 3. Okay. So times 3, right? That's all positive, right? All the denominator would be positive, wouldn't it? Okay. So by plugging negative 2 in the top, what do I get? It'd be negative, right? So it's a negative over a positive, so that means I have a negative. So what does it tell me about that because of that? Okay, so this should be a negative here, right? Okay, so this next piece right here, let's talk about let's not do the 1 again, right? Let's not have the 1, so let's plug in positive 2. Okay, positive 2 here. So let's see, positive. So on bottom I get positive again, don't I? Okay, and on top I get positive, right? Okay, so this piece is positive. So that means that it is going down to this point here and going up on the other side. But let's take a look at what that negative 1 is going to do to me. Okay, so let's go back to that graph. Graph here, doc B, clear that. Okay, so now my function, my original function was it x squared?
Yeah, x squared minus 1 all to the 2/3.
2/3 like that, right? Okay. Ooh, look at that. Okay, so there we go right there. That's the issue I was having, right? At negative 1 and 1, right? So can I take a derivative at that point? No. Cannot take derivatives at that point because it's a change in slopes here. So over here, so on this side, we had that it was going to be negative, right? It was negative, and this side we had positive. But now that little piece in the middle is going to be different, isn't it? Okay, so now because of that, let's take a look again. So that was my function. So now without graphing it, let's go back to our math to see what we need to do. So that took care of that, but because I couldn't have a derivative at negative 1, I could not have a derivative at negative 1. I know that is critical points there, right?
Yes.
That's positive 1 right there, not negative 1, positive 1. Okay, so because of that, I cannot take the derivative at that. So I'm not only worrying about my domain of this, I'm also worried about my domain of this. Because if I can't take a derivative at a point, that's going to be critical there. Right? So now let's take a look. So because of that, let's put in more numbers here. So on this side, it's going to be negative, but as you can see from negative 1, that was an issue. In between negative 1 and 0, let's put in negative 0.5. So a negative 0.5. Negative 0.5. So with a negative 0.5 here, changing to blue. All right, so negative 0.5. So that means that this is going to be negative on top, right? So negative 0.5. So when I square that, that would be a positive, right? So positive, but a 0.5 is less than 1, isn't it? So it's a positive that's less than 1. So that means that this whole thing right here is going to be negative, isn't it? That piece is going to be negative. So it's going to be negative times 3, which is also going to be negative, right? So a negative and negative makes that a positive. So this from here to here is a positive. Now I'm going to do the same thing on the other side. So positive 0.5. So positive 0.5. So a positive. So that makes the top a positive. But again, on the bottom, I'm going to still end up with that negative because it's less than 1 minus 1. So that's a negative. And the cube root is not going to get rid of that. So it's still going to be the negative there. So I'm going to have a negative. So this is negative. from that piece to that piece. So we had to address it from both sides, and we also had to look to see where is my derivative going to be not equal to. Okay? What is my domain of my derivative? Is there any place where I cannot take the derivative? And we found that as we were starting to plug in. Make sense?
Yes.
Anyone have any questions before I go on? No? Okay, let's move it. Domain of this function. What would be the domain of this function? Where would it start? Read from left to right. Negative infinity to 0. How am I closing 0? Open. Okay. What goes on the other side of that? What's got to go next? Union. Thank you. Union. How do I open it? Open. 0 to 2. Parentheses. It's open, right? Then it's union. Open. To what? Say positive infinity. Positive infinity. We're only talking about the domain, x values. Okay, critical numbers of f. Critical numbers. What's a critical number here? Anything else? 2, right? Why is 2 a critical number? Yeah, can't take the derivative there, and it's a jump. It's not continuous through there, right? What numbers x, if any, does the graph have a horizontal tangent? At what numbers x, if any, does the graph have any vertical tangents? Now think about it. A vertical line, what would be the slope of a vertical line? Undefined. Ooh.
So would it be 0?
Yeah, it would be 0. Okay, because it's going to be undefined there, right? It's going to be going to 0. I would have a slope but undefined. So eventually, when I get way up there, it's going up to infinity, right? At some point, the slope is going to be 0, right? Even though it's going to be right up to there, right? So that would be 0. At what number x, if any, does a graph have a corner? Is there any corners? Any place that I can't not take the derivative because it changes the slope? Goes negative, positive? Nope. Okay, none. All right, on what intervals of the graph increasing? Where is it? Negative infinity to 0. How do I close it? Open. What intervals of the graph decreasing? 0, 2. And how do I open? Positive infinity, right? That's an ugly infinity. Open.
Quattro, are vertical, are open jumps vertical tangent lines?
No, it's not always. It could be holes. It could be jumps. It could be holes. It could be. Are you talking about like this?
Yeah, it too.
No. Yeah, that wouldn't be. This is because of this. This is a piecewise. So it's any jumps like this piecewise. So it goes from here to here and here to here. So you're not going to get like any type of continuous function, because of this right here. So it has to be in 2 different parts of my function. So if you notice, this looks like part of a x squared, right? where the other part looks like a linear, right? So it's like a negative x. Yeah?
Right, so that's
Yeah.
the same function.
Yeah, so this is a piecewise function here. And so this is not going to be a vertical tangent. Thank you. All right. Let's take a look at this thing over here. Okay, so variation of the von Lingberg model states that the yield f of x of a plant measured in bushels responds to the amount of x potassium in a fertilizer according to the following square root model. Bleh, right there. Okay, for what amounts of the potassium will yield increase? For amounts of potassium will... For what amounts of potassium will the yields decrease? So there's an increase and a decrease, right? Okay, so first thing, I have to figure out what? Derivative! You guys aren't very, excited about this today. Derivative is going to be what? Negative 0.417 plus 0.852 over 2, right? Okay. Times x to the negative 1/2, right? Yeah, I did it kind of a lazy way, so I'm sorry. All right, so let's go ahead and put that x in the bottom, right? So if I put the x in the bottom, it's going to make life a whole lot easier. So it's going to be f prime of x is equal to negative 0.417 plus, let me see, that's 426. Okay, 0.426 over x to the 1/2. Yep. Okay, so let's do x to the 1/2 over x to the 1/2. Common denominator here to make it a little bit easier. So it would be f prime of x equals negative 0.417 x to the 1/2, right? Plus 0.426 all over x to the 1/2. Yes, because I common denominator, I multiplied this right here by x to the 1/2 over x to the 1/2, so I got that common denominator. So, you know what, I'm running out of room here. Okay, so I have f prime of x equals, what was that number again? Negative 417 x to the 1/2 minus plus 26 all over x to the 1/2. Now, I did this for a good reason, because I like getting rid of my fractions. I like clearing out my fractions. Like I said, we're going to set this equal to 0, right? So 0 equals so negative 0.417 x 1/2 plus 0.426 all over x to the 1/2. So clear out my denominator, right? Multiply both sides by that. So I'm going to take care of that. So it's going to be 0 equals negative 0.417 x to the 1/2 plus 0.426. Okay, move that over to the other side, right? Okay, move it to the other side, so it's going to give me what? Negative 0.426 equals negative 0.417 x to the 1/2. Divide both sides by negative 0.417. Negative 0.417. So it's going to be x to the 1/2 is equal to whatever you get there. You get something there, right?
1.022.
Like that, right? Okay. All right, how would I get rid of my x to the 1/2? Square both sides, right? So squaring both sides. So x equals this squared, which is going to give me
1.0444.
basically, right? Don't everyone jump on this all at once, right? Okay.
0.44.
Okay, something like that, right?
Yeah.
So is that a critical point there? Yeah, that's where it's going to be equal to 0, right? Yes. Okay. So that's where it's going to be equal to 0. So we know that I'm going to try and find both sides of that. All right. So given that, I know that I'm going to have my derivative. Okay. So the derivative. What's the domain of the derivative? And I haven't any issues with that one. Any issues with that one? What's the domain of the derivative? Is there anything that x cannot be?
All positive numbers.
Okay, it's got to be positive numbers.
It can't
And
be
it
zero.
can't be equal to 0.
Can't be 0. Very good. That's what we're looking for here. So it can't be 0. It has to be positive numbers, right? Okay. So that's good. So let's go back to our... Okay, so now, again, domain of this thing. Domain of this thing. Anything else I need to worry about? Same thing, right? Got to be positive numbers. Yeah? It's got to be positive numbers? Okay, good. All right, so now that I have that right there. So on both sides of this, I'm going to try and figure it out. So I know I'm going to have 1.1.044 and plug in numbers to the left of this. Okay, positive numbers to the left of this would be like, let's just plug in 0.5, see what you get. And let's plug in 1.5 on the other side.
Why not plug in 1?
You can do that too if you want. So I know everyone's calculating this right now because, you know, I get it, it's Monday, but yes, no, maybe? What about the 0.5? What's that 0.5 give me?
Yeah.
Positive? 0.5 is going to give me a positive. 1.5? A negative. So what does that mean?
That you don't want to have more than 1.044, whatever, for your potassium.
Very good.
Then you'll decrease your yield.
Yeah. So it's positive. So it's an increase from 0, right? So from 0 to 1.044, it is positive, right? So it's increasing. And I know from my 1.044 on the other side is going to be decreasing. R-E-A-S-E-I-N-G. All right, decreasing. Something like that. All right, so what does that tell me? You can't have too much of a good thing, right? If you put too much fertilizer in, you can kill your plants. So it goes down. So it's only good up to a certain point.
Is there a max?
Yes. So that's going to be a maximum amount right there. So you can maximize it at that. Make sense? Questions, concerns, complaints? Don't forget, like and subscribe. Notification button.